Hello and welcome to Metra Home Theater Tech Tips. I'm Brent McCall, and with me as usual, sadly today on the other end of the phone is
Adam Rogers. Hey everybody.
Adam is remote today because once again we are seriously socially distancing, and again we are filming from my home. So welcome to another live experiment. So before we get into today's tech tips, I do want to cover some interesting news today. For those of you who have not seen it, Crestron will be back at CEDIA this year for the first time since 2015. Honestly, I think that's kind of big news, and hopefully we have CEDIA. The other thing for those of us, or those of you that are in Las Vegas, you guys are lucky enough to get an early rollout of ATSC 3.0 May 26 on KVCW, the CW network in Vegas. So if you have an antenna and if you've got the newest in TVs, you guys can see the future with ATSC 3.0. One more thing before we go, I would also like to give a shout out to Rob Burris at URC. He called today because a dealer contacted him on how to program for one of our AIOs, right there. And Rob and I spent about 30 minutes on the phone going over what it is, how to use it, and some other things. So a shout out to him for being ahead of the game on taking care of their dealers. So I'm going to go over to Adam now because Adam had a unique call that we talked about briefly this morning, and I want you to fill me in on it, Adam.
Yeah, so the call this morning was kind of interesting. We had a gentleman call in, and he had a Roku 4K, and he was going through an older receiver that was still a 4K receiver. However, he was having some difficulties getting a picture on the TV. The TV was a newer Samsung, and when he would go through the receiver, he would get no picture, but when he bypassed it, he would get a picture. So after talking back and forth a little bit there, we found out that it was an older receiver, more than likely still on the 1.4 HDMI standard. However, because it was on the 1.4 standard and the Roku, of course, is a 2.0 and the TV is a 2.0, we had an EDID conflict, which was causing the picture from the Roku not to show up on the TV. So I put him on hold, and I called you up, and you and I discussed it back and forth. And Brent, what did we come up with?
I believe the answer was to put in one of the HDMI full 4K HDR switches with the audio breakout. This will allow him. We put in. Go on, Adam.
I was just going to say, we told him to go ahead and put that in there in its place because that's a full HDMI 2.0 18 gig switch. It also has the audio breakout function on it, so you can take the audio on the HDMI signal, break it out onto a digital toslink or a digital coax connection, and then go into the receiver at that point. So he took all of his sources, went into the receiver, and then went into the switch. And then from there, he had an HDMI going out to the television for video, and he had a toslink cable going to the receiver to give him audio. So he was still able to use an older receiver with the newer 4K signal and still have everything show up on the screen correctly and get the surround sound without having to upgrade the receiver.
Absolutely. Now, of course, this won't support Atmos because you do need an HDMI cable to do it, but the AVR wouldn't support Atmos anyway, so there's no loss there. So,
right.
Today's discussion is all about cables. What's real, what's not, and do they make a difference? And the short answer to that is, yes, they do, but we're going to back up in history. Very early on in HDMI, the second year we showed product at CES for HDMI, some gentlemen came up and they were filming around the show, and they said, can we ask you some questions and tape it? And one of the questions was, are all HDMI cables the same? My response, which was politically correct at the time and a little bit naive on my part, was assuming that all the cables are in fact built to and tested to the HDMI standard, there should be no difference. Now, I'm here to tell you that particular statement has haunted me till this day because it turns out I was wrong. The HDMI standard is less of a standard and more of a suggestion, which can create some problems for dealers and consumers out in the field. So we're going to get started on that now, and I'd like to say thank you to Apple TV and screen sharing. So let's talk a little bit about what data is. When you're looking at data, there's traditional ones and zeros. High and low, on or off, yin and yang, whatever words you want to use. Now, the interesting thing about digital data is when you look at this, it is still an analog waveform. It is red at the top and it is red at the bottom, but it's still an analog waveform. And where the problem comes in is where the data is actually read. Some devices will give you a wider window than others. Some devices have more EQ going into them than others, devices being AVRs, switches, or displays. So if you've got a signal that may be not as strong, but you've got a TV that has a lot of equalization, it will work. It has a lower threshold. If, however, you have a TV that doesn't have a lot of EQ and your signal is not as strong, it will not work. Same cable, different system. Now, this is the goal of all data, ones and zeros. This is closer to the reality, just basically going through a scope with a super clean test cable. This is not an HDMI cable. This is just the really short pigtails that are used to go into the HDMI boards. Now, when you're looking at a cable, here's what becomes very important. You've got 4 individual runs in an HDMI cable. And currently, only 3 of those runs, D0, D1, and D2, are video and audio or high-speed channels. The 4th channel, D3, is currently today under HDMI 1.anything and HDMI 2.0 just a clock. All it has to do is tick to reconnect D0, D1, and D2 together. But they all have to line up in time. These are the signal crossover points of the twist in the individual conductors. So when you're looking at the cable, if these twist breaks do not hit at about the same point, you run into timing errors. And the problem with timing errors is they are cumulative. HDMI, the guidance is no more than 6/100ths of an inch variance between point A and point B, regardless of how long that chain is. It could be a cable box to a TV. It could be a cable box to an AVR, to a matrix, to a TV. It can include a splitter. It can include an active cable. It can include a repeater. You don't know. But the total variance approved or allowed under HDMI is 6/100ths of an inch. And in order to get a good idea what 6/100ths of an inch is, take a dollar bill out of your pocket and look at it because it's 1/100ths of an inch thick. That is all the space you have to work with. Your typical component, television, AVR, matrix cable box, will take 4/100ths of an inch for themselves using the rationale, well, everybody else will do it right, so I can save money and fudge. So assuming you have just a cable box and a TV, you have already breached the 6/100ths of an inch barrier before you even add a cable. So this becomes very critical in the twist ratios within the cable. That is why cheap cables do not perform as well, even if they have a beautiful eye pattern. And eye patterns are kind of interesting. We're going to skip to that real quick. An eye pattern is a 1 and a 0 done many, many times. Now, there'll be a mask in the middle of this that's considered the area where the data cannot touch. If it touches, it breaches, and that will look like that. A good eye pattern looks like that. You've got space above and below. Remember, 1s and 0s. Here's where you have to pay a lot of attention. And this is one of the things that most marketing companies will do. They'll show you an eye pattern. And it's a beautiful eye pattern. Look at that space. Everything's clean. Nothing's touching. But what you really want to know is not that one eye pattern. You want to see all of the eye patterns. Show me the 3 eye patterns together. Do they sync up? And if one of them's out of sync, you're going to have a problem. There's going to be timing errors. And back to what I was saying about timing errors earlier, those failures are cumulative. because there'll be a little timing error in the cable box, a little timing error in the TV, maybe a timing error in the AVR, and you add that into any errors in the cable, and it can cause failure. So you want a cable that's properly designed with minimal twist differences between the different runs. And remember, there are 4.
And Brent, what does the difference, what does it look like when there is a timing failure? When you look at, let's say we do run into an issue where the cable is bad, one of the devices in the connection pathway is bad. What does the failure of timing look like?
Well, the interesting thing about HDMI is there's not a lot of different symptoms for failure. The first symptom is if it's bad enough, you get sparkles. If it's a single color, it's either the D0, D1, or D2 that's failing. If there's no picture, it could be D3 because the clock's not resyncing. And if it's white, the entire cable is just way past its bandwidth capability. Now, you could also have no picture at all. And no picture at all could be any number of reasons. The only thing that's actually reasonably diagnosable in the field is snow. Because you can look at it, if you see snow, a single color or multiple colors, the cable is bad. That's about the only simple diagnosis in the field that's that's that problem. A black screen, mode out of range, frequency not supported, HDCP error, all of those can be caused by any number of things, or more importantly, a combination of things. So the goal is...
And is there anything that can fix that?
Well,
do we have any device that
there
we
are
have?
devices that help do this, and the first thing you would use is our EDID repair. But ultimately, the goal is to not have to repair the system. And the best way to do that is to put the best of everything in the chain. Now, we DPL certify our cables, Digital Performance Laboratories. A lot of you have been to our shows at CEDIA, and you've seen Jeff Boccaccio stand up there and do his best to scare the heck out of you, to warn you that, look, cables do make a difference. There's a lot of things to concern yourself with, and DPL is doing their best to make sure that when you get a cable, it has been tested to a phenomenal eye pattern. Now, as a DPL member, when we submit a cable for testing, we don't just get an eye pattern, we get a breakdown of all the eye patterns, D0, D1, D2, the clock channel, how they line up, the quality of every channel, are there any variances? You're looking at interpair skew, intrapair skew, and the difference is there. Let's back up a second. This is interpair skew issues, where the timing is wrong on the different sets of cables, on the twisted cables. This is intrapair skew. We've got the center point of the cross, where the wire gets twisted and crosses over, but the center point's not correct here. It's longer on one side than it is on the other. This can also cause errors. Now, it is not uncommon to have a product where, let's say, the green channel's a little weak. Now, if you have the blue channel slightly bad in your cable, and then the red, the green, and the blue work on the next device, you're probably in pretty good shape, because they're still kind of there. But if you have the green channel bad on your source and the green channel bad in your cable, that cumulative error is what causes your issues. So it is possible to take a system, swap out another cable, and suddenly it works. And the reason it's suddenly working is because that cable has fewer issues within it than the previous one. So we're back to certification of your cables. HDMI certification tells you that the company is giving them, HDMI them, money. DPL certification tells you that the cable has actually been tested to well above the HDMI standards. And that's really what you want. Now, when you look at cables, these are different views of an eye pattern. A really good eye pattern, a marginal eye pattern, and a collapsed eye pattern. Now, think about it like this. You're a kid, you go out and you find yourself a nice stick that's got a V in it. You take that stick and you put it down on the sidewalk and you start dragging it because it makes nice lines on the sidewalk. When you start dragging that stick, the lines are nice and far apart. Over time, because of friction and wear, those lines get closer and closer together. The exact same thing happens to a digital signal within an HDMI cable. At a shorter distance, it looks beautiful. As the distance starts increasing, the voltage swing between high and low starts to diminish because of loss within the cable. Now, this can be caused by the design of the cable, the materials of the cable, the dielectric, the winding, the solder joints. All of this adds up to a cumulative failure. Now, when we DPL a cable, they DPL based on bandwidth and distance. What should that cable do? Does it give us this? So if you get a DPL'd 4K cable at 10 meters, for example, our VLOX 10R2 at 10 meters, that is a full 18 gigabit cable. In our case, 24, we'll get to that in a second. But you may not see that distance for DPL certification under other lines or other brands. So look for the DPL certification because it definitely covers your butt. Now, we're going to go back to the iPad in a second. If you see right here how this one's collapsing, it goes from 1 down to 0. The problem is this is time related. Go to a bedroom door in your house. Open that door full width, close that door full width. Now I want you to start speeding that up. The faster you go, you're approaching digital data. Now digital data moves very, very, very quickly. The drawback is in order to make any kind of movement as you increase the speed, you'll start diminishing how far you can open that door. So it starts to collapse on the center to the point that somebody cannot get in or out of it even if they can move fast enough. The same thing happens to cables. You reach a point where it's just not going to support the bandwidth. And that is part of the reason we're seeing such a large push toward fiber. But up to 10 meters, for example, you can support everything within the 24 gigabit domain. And let's discuss that real quick. When you're looking at cables, up until recently, this is the 4 channels within a cable, D0, D1, D2, and D3. Only the first 3 carried video. The 4th channel was the clock, and all it had to do, again, was just tick away. Nothing really important, not a whole lot of data, it was just there. However, under HDMI 2.1, that changes. Now, all 4 of those channels are handling full bandwidth. Now, we test our cables to 6 gigs per channel, and we build our cables to 4 high-speed channels. And as I've said in the past, I'd like to claim I'm a genius. I'm not. We just never really cheated. We just happen to be prepared for the future because we don't cheat. So all 4 of those channels will handle 6 gigabits per channel. So that's the 24 we're at now. But the future is higher. The future's taken us to 12 gigabits per channel. At least that's what they tell us. However, the more we've studied the specification, the more we find out what's going on. The reality is, in order to get HDMI certified, you don't have to hit the full bandwidth on all channels, you just have to hit some of the bandwidth. Now, for example, this cable gives you 3 on D0, 6 on D1, 12 on D2, and 6 on D3. So you're not getting 48 out of this cable, but you are functioning. So it is our assumption that this cable will pass. It is not a good cable, but it's a passing cable. I would not put this in a consumer's job site because it's not 48. What you've really got is 18, 21, 27 gig. Because there's multiple EQ channels on each run, it will function. And this was done so that when somebody goes to Best Buy or Target or Sears, buys a panel, they take it home, they plug it in, they got a picture. They don't have the failures that we saw in the past with a black screen or noise because the system automatically adjusts to its best possible bandwidth. However, that is not the best possible picture, but it does work. So it knocks down on the returns to the manufacturer, knocks down on the returns to the retailer. It gets somebody that's a marginal installer in and out of the house quickly without having a lot of worries. However,
so Brent, one thing that I want to make note here real quick. Just I'm going to jump in. This all sounds very doom and gloom. It's going to be very difficult, and that we're going to run into problems and everything else, and that's not really the purpose of what we're doing here. We really want to get out there
And honestly,
and show everybody that this is going to work. We want to relay the information to you, the installers, to you, the dealers, and even to the consumers that watch these shows, that we are fully aware of what's going to happen, and we are getting out there ahead of it. We want to make sure that you do have the best quality products. We do want to make sure that you do have the best quality repairs to make sure that your clients that are out there, they have something to put in there to make it work.
Absolutely.
So we're really just wanting to get this information to you so that you can be aware of what you are going to run into out in the field, so that when it does happen, for one, you either will already have the knowledge, or you'll know that you can lean on us for a fix when the time does come.
The goal is to not have to put a fix in, and that's when we build the cables the way that we do. When you look at everything we're selling now within the Ethereal brand, MHX, MHY, and VLOX, it is all 4 gigs per, or 6 gigs per channel by 4 on all the 18 rated cables. They're actually starting to go over to 24. Now, once you get above 2 or 3 meters, 48 gigs becomes very, very hard on copper. We think we can do it, but it hasn't been done yet. There's still a lot of formulation going on. At that point, you're looking at adding repeaters, some kind of electronic device that will take the collapsed data, like this, and rebuild it to look like that. That is a repeater, an active accelerator, in our case the GA1 for 24 gig and the GA2 for 48 gig. However, the other option, and we're starting to see a whole lot of applications of this, is to move to fiber. Once you get past 10 meters, 48 gig, even with active restoration, is going to become very, very hard and expensive. Not doom and gloom, just reality. That is why fiber is the better option, assuming it's built correctly. And purely from a price point, it is absolutely taking over the longer distance markets, because it gives you, right now, 24 or 48 on the new VLOX, up to 100 meters, 330 feet. So you can go a long distance and have the performance level. And as we discussed on Fiber Friday, last week and 2 weeks before, when we go past the 48 or the 24, if you've installed that cable, all you have to do is cut the ends off, install LC or ST terminals, whatever the terminal du jour is, put it on an extender, and you're ready for the future then. That is why you want to use multi-mode instead of single mode. It takes you a lot further into the future once you get past 10 meters. Now, today, the near future, the next 5 to 8 years, copper for racks, copper in a typical installation where you're going anywhere from 18 inches to 9 feet, is still going to be the preferred format, assuming that cable has got 4 high-speed identical channels. And here's why. A passive cable, properly built, let me say that again, properly built, will give you much more flexibility between the devices than an active cable will. An active cable, due to the electronics in it, has to make some assumptions. It has to work on what it perceives the threshold and the source and the display will be. A properly built passive cable does not have to do that. It just has to be built where all the channels give you the same bandwidth. All the channels give you the same inter and intra-pair skews. And assuming you purchase a DPL certified cable like the Ethereal MHX, MHY, and VLOX cables, you are in great shape to move forward, because that has already been done. And in fact, in our case, it's been done for as long as we've been making HDMI cables, all the way back to the original EE and EP series cables. We have always built them with 4 equivalent high-speed channels. Anything to add, Adam?
No, that's pretty much it. You've kind of covered pretty much everything that we've got for today. I don't have any questions in the comments today, which is fine. Just remember, guys, if you are checking into this live video after the fact, you're coming in and watching it on the recording, if you do have questions, please put them in the comments down below or in the chat as well. And we do check on that regularly, so if you do leave a comment, we will get back to you just as soon as we possibly can. As always, you can contact me at the tech support line at 386-492-8584, which is the best way to get in touch with me. You can, of course, email me as well. My email is adamr@metrohometheater.com. And then, Brent, your contact information?
My contact information is on RC and IP on the website, but it's 386-846-7264. And one other thing I would like to add about cables, because we see a lot of inexpensive cables out there. If you're doing a control system, and if you're doing a rack or equipment going into a cabinet with a control system, a cheap cable will cut costs to get their price down by removing shielding. Now, this is important because when you look at an HDMI cable, the shielding is not there to protect the HDMI signal. The shielding is there to protect everything else in the world from the HDMI signal. A number of years ago, Stuart and I were working on testing some stuff, and we found that on one of the jobs, on one of the testing that we're doing, our URC system quit working. URC was kind enough to send us remotes and processors for testing. We also had Crestron and RTI. But in this particular day, we were doing URC, and we found that on some cables, the URC system would not work at all. Once we took that cable out and replaced it with another one, the system was fine. First thought was, well, there's a grounding issue. There wasn't. We dissected the cables, and what we found is no shielding. The noise inside of these high-speed channels is very loud. And for those of you that have toner wands with inductive amps, put it against the cable. You're going to hear a lot of noise. It kind of reminds you of the old fax days, except a lot faster. That noise is loud enough on a cheap, unshielded cable to walk over everything else in your system, your RF, your IR. It can interfere with your other signals. Don't put in cheap cables. They will bite you in the butt. It doesn't mean you have to spend a ton of money. There's some great product out there that's DPL certified. Obviously, MHX and MHY from us. But don't put in cheap cables. It makes a difference. As usual, any questions, give us a call. Please like us on Facebook, like us on and subscribe to our YouTube feeds, Twitter, Instagram. Contact us regularly. I am available from 8 a.m. to 10 p.m. 7 days a week. Love to hear your calls, love to hear your problems and your solutions. And if you got a good one, you had to make our weekly broadcast, or twice a week broadcast. And next Friday, this coming Friday, is what, Adam?
This coming Friday, we are going to have JVC and Deep Dive AV. We've got Chris Deering from Deep Dive AV on the call with us this Friday. We're going to be discussing theater calibration and things to look out for on theater calibration. So definitely come in and check us out for that one as well. And then next Wednesday, we are going to have our friends from True Audio. We have, pardon me, I'm forgetting the name, but we've got True Audio going to be on a call with us. We're going to be discussing a 70-volt audio system. During that time, we're going to discuss, if it's right for this project that you're currently designing, or if you should stick with an 8-ohm system, or if you need to do something else. And then, of course, the Friday after that, we are doing an episode on surveillance. This is one of our few episodes that we're doing on surveillance so far. We're looking forward to doing it, and we're going to discuss on that one how to do some surveillance design, as well as different ways to lay things out for that. So definitely check us out. It's going to be this Friday at 3 p.m., next Wednesday at 3 p.m., and the Friday after that at 3 p.m.
And
as
certainly
well, Eastern
on the surveillance,
time.
we are absolutely seeing a major increase in surveillance during COVID. People want to find out what's going on in their warehouses, at their stores, and their restaurants as they're reopening. So there's a lot to learn in that one, and Adam is really strong in that subject. So please join us. And what do you want to do at the end of every day, Adam?
Reboot your equipment early, often, and as soon as you can.
That's right. Thank you for joining us. I'm Brent McCall.
I'm Adam Rogers.
And with any luck, we'll be once again broadcasting from the office on Friday. Thank you, and have a good day.
Thank you.